Hey guys, and welcome back to another YouTube video. This video is gonna be a really cool one because I'm gonna be talking about something that is really kind of a topic around which there's a lot of like stigma developed in deep learning, and it is backpropagation. So if you are familiar with deep learning, you are probably familiar that backpropagation is very difficult and complex and whatever. And in this video I'm gonna try to break that statement. I'm gonna show you that it really isn't that complex. It is pretty simple if you know what you're doing. So first of all, what is backpropagation? Because I'm pretty sure a lot of people who are just starting out with deep learning have absolutely no idea what I'm talking about. I mean, what's a backpropagation? What is all that? So in this video, I'm really not gonna be. I will not be diving into every single detail of backpropagation. Rather, I'll just be diving into like the more important stuff that is more stuff that I really need to cover to actually explain you the mathematics behind backpropagation. So I already kind of shot like a few instances of this video, and I really am the reason why I'm doing this again is because I really want to make like a video where you guys actually understand what's going on, even if you don't know the math. Like obviously if you don't know the math, you won't be able to actually like really understand what is going on, like all the details, but you'll at least get a brief idea. So backpropagation, I hope I spelled it correctly. That's my only concern right now. All right, so the first question that I hope everyone asks is what is backpropagation? Because that is really important. You can't just go ahead and perform backpropagation without knowing what it is. And the thing is, all of these new kind of neural network frameworks, like we have TensorFlow, we have PyTorch, and all of these frameworks are gonna be performing backpropagation by themselves. So you really won't be seeing like stuff happening. Like for you, it will just be you're just training your neural network, but in reality you are actually doing your forward prop and then your back prop. And so that's why not a whole lot of people have an idea. Now I know that creates the question, well, if these frameworks are handling all of this, then why should we even learn this? The reason why anyone should learn about backpropagation is because if you are trying to develop your own neural networking framework, you're gonna have to write a forward prop and a back prop for every single layer and activation and loss function that you develop. And if you don't know what backpropagation is, you just won't be able to write the entire backpropagation part, which is very essential to neural networks. You cannot have a neural network without backpropagation. It's just stupid. And that's why that's the first reason for you learning backpropagation. Another reason is the fact that a lot of the times you will encounter some bugs and stuff in your neural network. And the best way to if you're just going to be knowing the code, like the how to implement a neural network in like TensorFlow or PyTorch, you might not be able to actually identify those bugs, the source of the bugs. And you'll only be able to do that if you know what is going under the hood. So if you know what forward propagation is, how it is performed, and then if you know how you take the output of the forward prop and then you back propagate it, only then you will actually kind of get a better idea of what is happening, which will allow you to fix that bug. And thus backpropagation is important. So now let's get to the what. So if you have like a neural network over here, and you can kind of split a neural network training process into two like fundamental processes. I don't know if you can call it that, but all right. So the first process that you really need to consider is the forward prop. I don't know what's up with my mouse today, but forward prop. And then you have your backward prop. So these are like your two processes. Now forward prop is really just like you have your layers, you have your activations, and then you have your cost. So really what you're gonna be doing is you're just gonna like some output, which is just gonna do your uh, you're just gonna, why can't I switch? There we go. So you're gonna take your inputs, you're gonna dot them with your weights, and then you're gonna add your bias term, and then you take your z, and then you add probably some activation function, which I'm just gonna denote by, I don't know, sigma, and then you just put in like your this, which is just gonna be c is equals to. So this is in your entire forward propagation. So this is like your entire neural network forward prop, and then you probably add like a loss on this, and because you probably have like a few times, maybe 2 times, 3 times, 4 times, and then you'll add your loss. Backpropagation is basically you so in this case, as you can see, what is really happening is we are moving from our inputs to our hidden layers, and then we are basically doing as many hidden layers as it is, and then our nth hidden layer, we are then moving on to the outputs. All right, so this is more of like, as you can see, the intuitive explanation. I'll dive into the math in just a second. So we have the outputs. All right, now here's the deal. The way we actually optimize our neural network over the successful iterations and our successful epochs is if we know how every single weight parameter affects the output. So if you know that, so what you need to know is, let's say you have like 5 weights in your neural network. What you need to know is how does each of those weights, how does weight 1, by what magnitude does weight 1 affect the output, by what magnitude does the weight 2 affect the output, weight 3, and so on. If you have a bias term, you also have to take into account the bias term. So if you know how much each of those things affects your output, what you effectively know is you have a very good description of exactly what affects what in what way, and so you will know how you should tweak your weights in order to get a better output. So let's say like weight 1 affects the output a bit too much, and you probably wanna, and it's giving you like a good accuracy and stuff, so you know how to tweak it, and that's really just the essence of backpropagation, and that's really why it is useful, and it's just an integral part of neural networks. You cannot have a neural network without like backpropagation. So yeah, so now that we have looked at kind of like the intuitive meaning of what backpropagation is, and why we should do it, I think uh, we have enough knowledge to actually dive into the more niche details, if I was to call it. This isn't something everyone will understand. Maybe some people might not understand, but yeah. So before I even start, I obviously wanna give you guys a good kind of uh, idea of what math we're gonna be using here. So the prerequisites, and the prerequisites are pretty like just one thing. You need to know your calculus. If you know calculus, more importantly differential calculus, all of the derivatives and stuff, only then you are gonna be able to understand what it is that I'm doing here. If you don't know that, then please just stop watching the video right now, and you should probably just look at this definition, learn your calculus, and then get back, because you will not understand like 90% of what it is that I'm saying over in this part, because this part is going to be purely a little mathematical. You don't need to be a master at it. Just know the basic rules and know what it is. So, all right. So the way I'm gonna be teaching you backpropagation is something that I learned from another channel named Andrej Karpathy. The reason I'm gonna be using that style is really because the way he uses scalars to do it rather than like matrices, it really becomes a little easier. I also saw that a lot of books like the Mathematics of Machine Learning, which is another really good book, whenever they're teaching backpropagation, they always use scalars. And to be honest, that's really good thing, because the thing is, if we directly dive into matrices and all of that matrix math, believe me, it's gonna get really crazy, because we are gonna be using a lot of really crazy stuff. Like, what I mean by crazy is that it's not gonna be like very very advanced math. It's just gonna be, it's very involved. So if you even screw up one thing, it really doesn't make any sense. All right. So first off, let's look at a scalar equation, and let's look at how to backpropagate it. So let's say we have something like this. We have 20. Oops, what is happening? Alright, we have 20 is equal to 5 times 3 plus 5. Cool. So this is the equation we are using, and I know what you are saying. This doesn't make a lot of sense, right? I mean, this just doesn't make any sense. I mean, all of these are constants. So now, basically, the first thing we're going to be doing is we're going to assign variables to these. So I'm going to change my ink color just to assign the variables, and then we are going to just change it back again. Alright, so the 20 here is just going to be a y, and this is going to be a a. I don't know what's up with my mouse today. B and C. Alright, so now what we need to do is we need to construct a graph of this equation. Now I know what some of you might be saying. What do you mean by a graph? Well, whenever if you have done like an introduction to programming, you might have always seen that we always construct in like the very introduction, you would see a lot of people trying to construct a flow chart for the program that they are doing, and that that kind of helps them plan out exactly how they want to do it. Well, that's really what we are doing. We are constructing a kind of a flow chart, the exact like what is happening and how it is happening, and in this case we just call it a graph. So now let's just construct this graph. So what we have here is we have a square which is going to be your digit, so we are going to have a 5 here, and we are multiplying it by a 3, so you're going to have a 3 over here. So we have a 5 and a 3. And now we need to multiply these two things together. So we put a circle and then we just put in like your operation. So it's a multiplication. When we multiply the two, we end up getting okay, that square is kind of bad. Alright, so when we multiply the two, we end up getting a 15. And then as you can see, we are adding a 5. So we need to just make another square here, and we put a 5 over here. Just do that, do that. So it gives you 20. Alright, cool. So now we can go ahead and assign our variable. So that's going to be your y, that's going to give you your c, that's going to be your a, b, and since this is like an intermediate, I'm just going to call it an I. So there we go. So now we have all of our variables. Cool. So now what we need to do is we need to actually backpropagate this. So what we really need to find is we need to find dy by dc, dy by dA, dy by dB. That's like if you are really looking at a neural network, then that's what you're going to be finding out. Because if you look at it, this is just the equation of a forward pass that I've written over here, like a basic forward pass without a activation. But in this case, we're also going to do dy by di, just because I want to give you the practice. So yeah. Alright, so let's backpropagate this. So the first thing is dy by dy. That's really what you need to find. And that's just going to give you 1, right? Because the change in y with respect to y is just 1. So dy by dy is just going to give you 1. And I'm not even going to walk you through that. I mean, that's... Alright. So the next thing is, let's say we want to find out dy by di and dy by dc. Alright, well, that's pretty simple stuff. Alright, so what we have here is we have a I, C, and a Y. And what I need you to do is I want you to construct an equation to obtain Y using our variables over here. Now, really, the way I would recommend that you do this is just say we have an A here, we have a B here, we have a I here, we have a C here. The easiest way to get the value of y is to add I and C. So that's really all we are going to do is we just say I plus C, it gives you y. So now when we are saying that the change in y with respect to I, so the derivative of y with respect to I, some rule basically says that this goes up to like 1 because this is I raised to the power of 1, 1 goes down, this becomes a 0, so this becomes a 1, and then we have the C value over here, right here, which just goes off to 0 because it's a constant. So we get 1 here, so the grad will be 1, the So then if we say dy by dc, well, that's also just gonna give you 1, right? Because it's an so because like it's just the same thing. In this case, this goes off to 0 and this goes to 1. So as you can see, it's actually very, very simple stuff. All right, moving on. Now we need to figure out dy by dA, and that's actually, you might see, well, that's not that easy. I mean, doesn't make that much of sense. But to be honest, it's actually very basic. It's pretty simple. So let me walk you through that. So the first thing is, we know the value of dy by di. Just keep that in mind. And the other thing that we know the value of is we know the is if we know the actually we need to find the value of that first. I don't know why I just said we know the value. Basically, the other value we need to find is di by dA. So we know that I for a fact is equals to a times b. So if we say what is di by dA, well, that's just gonna give you b. And I'm just, so we don't have to do this later on. I'm also just gonna say what is di by dB. Well, that's just equal to a. And believe, that's nothing. That's just product rule. I'm not gonna, not actually not even not that's not product rule. That's just like constant times the variable rule. I don't know the name of that rule, but whatever. So yeah, so we have this gives you b and this gives you a. All right, so now we have the derivatives over there, and we as I just told you, we also know dy by di. So now when we are finding out the value of dy by da and then dy by db, this is all you need to do. Well, the very kind of people who are really, they know their calculus, they'll probably just note that this entire computation, this entire dy by dA and dy by dB, is really just going to be the chain rule that we see. And just to refresh your memory, if you have some f of g of x, that is equal to the f prime of x times the g prime of x. That is your classic chain rule. Uh, all right. So if you just look at that, basically what we are doing is we are multiplying the two together. So all you really need to multiply to find dy by dA is just di by dA, which is gonna be like your g of x, and then you're gonna be having like your dy by di. So you're gonna be taking dy by di. When you multiply the together, so you can do a dy by dA. That the dy by di is just 1, and the di by da is just b, so that's gonna give you b. So the dy by da is b. All right, well, now we have to do a dy by db. So dy by db is equal to di by d a. Actually, not di by da. Yeah, it's gonna yeah, that's gonna be a dy by db times dy by di. So when we do that, the dy by, let me zoom in a bit, it's lagging a bit, so yeah. So when we do a di by db, this again, di by, the dy by di is just a 1, and this is just gonna give you an a. So there we go, that's your value. So now you can just substitute the values of a and b in this case, and there you go, you have your answers. So you can just kind of uh, put a box around these if you guys want to do that. So there we go. That's your backpropagated function. That's literally it. That is all that you need to know for backpropagation. Obviously, we are looking at like scalar backpropagation right now. This is not matrix backpropagation. And to be honest, like this stuff, there are several auto differentiation libraries out there which handle all of this stuff for you, so you barely need to actually work this stuff out by hand. And I mean, you might be like, well, yeah, it did take us a little bit of time, but this doesn't look that crazy. Well, just imagine if in this case this was like a 600 by 600 matrix, this was another like crazy 600 by 300 matrix, and then you had this matrix over here, it would get pretty crazy. So Yeah, so that's why this stuff is really just done by computers. Computers, like, we don't do this stuff by hand, but it is important to know it, basically, because if you develop like your own, just as I said, any framework, you're gonna need to do this stuff. So yeah, that is really all about backpropagation. And yeah, so this video was pretty self-contained in terms of, I didn't exactly expect any knowledge in this case, and I hope you actually understood what it is that we are doing here. If you kind of got lost in the math here, I would recommend that you can rewind the video, go into this entire intuition section, and you will understand exactly why we are taking derivatives with respect to y and a, y and I, y and c, and y and b. Alright, and if you still don't understand, that means your calculus isn't clear. You should probably understand the intuition rather than just the formulas, because you can get only so far using just your formulas. You really need to have your intuition down. You need to know what's the rate of change and why you even take a derivative in cases. Because if you don't know that, then it really doesn't make any sense. It's just basic algebra once you know the intuition. So yeah, I won't really go into that stuff right now. But yeah, so that's basically it for this video. I hope you enjoyed it. If you did, like, subscribe, and comment down below what are the types of videos you want to see. And I'll surely try to put them together. So, just before I even end, I would highly recommend that you check out the Andrej Karpathy's channel that I mentioned previously. You check out the Mathematics for Machine Learning book, and I would also recommend that if you want a little more of a visual kind of animations and stuff, then you can also check out Three Blue One Brown's channel, wherein he has gone over like AI and like uh, backpropagation and cost functions and stuff, which is pretty good. But yeah, seriously, I cannot recommend these three sources enough. They are really good and really genuine. All of them know what they're doing, and you can rely on them. So yeah, that's it for this video.